So the next thing I want to talk about, just at a really high level, is the module pattern. The module pattern, there's a little more to it, but in essence, the module pattern is a way that you can modularize your code, or you can do things like make sort of class-like structures in JavaScript. It's a way to construct sort of like an API, which is just like an interface of interacting with your data. And so, for example, you can have some private methods and private properties. And then this returns an object that has some public properties, which can be accessed by the public. And there's public methods that can be run. And then there's a privileged method that could access the private method. And what this does is this limits what your application can do with the data inside of here. And this is just sort of a overview. And we'll go into like more detail of like how we'd actually use it. And so here's an example of a car function. It's a constructor function. We can create different kinds of cars like this. This would be like if you had a car game and you didn't want people to cheat and change the gasoline level. Like maybe it's like the most boring car game ever, where like you keep going until you run out of gas. And so how you would what you would do to sort of limit that cheating is that we'd have this privileged method here that's called go, which calls use gas and passes the speed. And so what this does is that you can't change the gasoline level directly on the car. And let's just run this just to kind of look at it. So, oh no, my timer's still going. So we have here our car, so we can say like var. What's the kind of car? I don't know.
Ferrari.
Ferrari. How do you spell Ferrari?
F-E-R-R-A-R-I.
Okay. Equals car. Does it take anything? No. So now we have our Ferrari and we can look at it. So a Ferrari is an object that has a go function. You can change the radio station, and also you can just see the radio station. And so if we wanted to say Ferrari.go, and we can pass our speed. So let's say we're going to, everyone goes, the speed limit's about 2, right? No? Okay. So quiet today, guys. And so you can keep going until you run out of gas, and it will print out of gas. And so we see here when we use gas, we pass it speed, and it goes up here. And use gas is a private function. So we can't change how the gas is used. And so this would prevent someone from cheating on the car game, where they would give themselves more gas than someone else, for example. And the whole idea here is sort of abstracting away what is important and what is not dangerous for someone to use. If you think about just the car metaphor in general, when we talk about APIs, we would say like so to drive a car, you don't have to know how the engine works, right? And in fact, it's better that when you're driving the car that you're not touching the engine. You're just only touching what is public to you, which is the steering wheel, maybe the ignition, the shifter thing, you know. And so our car API is abstracting away how the engine's actually working. So you can drive a car and not actually understand how the engine works. And it might be dangerous if you did and you went in there and started messing around with it and then it broke. And so that's the same idea here. So we have some things that are private in our car, like the gasoline level and how to use the gas in general, whereas something that's less dangerous, like changing the radio station or just going. So go would be like pressing the ignition. We have access to that. And so we can use closures to create an interface like that. That makes sense? Thumbs on that? Thumbs. Cool.
So is this kind of building on the closure?
Yeah. So this is using a closure. See how we're returning this object?
Use gas is kind of the function within the function?
Yeah, exactly. Exactly.
Okay.
And that's just another way to think about closure. Any questions about closures? Because we're going to keep moving. We're good?
Make a comment on that, where before when we were naming a function, it was at global scope. This one is not. It's at the function scope because it's defined within that function.
Yeah, exactly. And you can use the module pattern to organize your whole code base into different modules as well. And so you have like private components of your app that you can use. So the module pattern is used all over, and this is just a simple example of like how we could use the module pattern to make classes as like a factory to make objects.
Can you call a function within one of the functions that you're returning? So for example, here, could you call the go function within the change station function?
Yeah, you could. So now we're going to talk about higher order functions and callbacks. So what is a higher order function? So a higher order function either takes a function as an argument or it returns a function as an output. So we've done a lot of returning functions when we're going through closures. Now we're going to talk about how functions take functions and how to master that. So then we can, once we get to deep diving into our functional programming stuff, we will like have those concepts mastered and it won't be confusing, hopefully. So here's an example of a function taking a function as an argument. So this is adding a click event. And then the callback would be this function here. So a callback is a function as an argument. And then here, this looks familiar to us because we've just been doing it. And this is returning a function from inside a function. Cool. So callbacks. So here's an example of an if-else statement abstracted into a function. And so in functional programming, we're using functions rather than procedures, I guess. Or we're using functions as units of abstraction versus abstracting over data in functional programming. And so some silly example is you could just use an if-else function instead of an actual if-else statement. And so here's an example of that, where we are passing a condition, and then we're passing a callback function for the true condition, and then we're passing another callback for the is-false condition. So here, for our example, we are just passing true. So the condition is true, and it's going to call, or it's going to enter into this block. And so what's going to happen when this code runs?
Console log true.
It's going to print out the function, the content of the function.
All very good guesses. So what's actually going to happen is it's going to return undefined. So we're not returning these things, and we're not calling them. Oops. So it's important to note that when you are doing this, you need to call it. And so when we call a function that's a parameter or that's an argument, it's just like referencing it as a variable. So if we wanted to call is false, we just add the invocation operator, also known as two parentheses, next to that function name. And so these are two anonymous functions that we're passing in. But we could also pass in other variable names. So if we have this function stored at log true, we could pass it then as log true or log false. And that would work just the same. Is true would then be log true, would be this function. And is false would then be log false. And so if we did this, what would happen? What's going to happen? Kim, do you know? What is it?
Log false.
Yep, it's just going to log false. Exactly.
You had a previous slide? No, silly question. You can't put the invocations in the in the parameter?
No. So
That's just bad syntax or whatever.
yeah, we just give you an error. So the thing about parameters, they're just like uninitialized variables until you pass an argument. So just like a variable, you couldn't call, like if we just had like var x here, you know, it's just an uninitialized variable. You can't call x because x is just undefined. And so it wouldn't make sense. Like we're just here declaring them as like undefined, just saying like if there's an argument passed in this place, it's going to hold a value. If not, it's just going to be undefined.
There's a question in the chat room. Can you walk through this step by step? They're stuck on the if-else function and how it works.
Oh yeah, sure. So here, let's do it in the next slide. So how our browser would read this, it would say, okay, great. We're creating a space in memory called if-else. We're going to store a function there. This function just happens to have 3 parameters by these names, which at this point they have no value, right? Then we say log true is another function. Log false is another function. So then we pass to our if-else false, log true, and log false. So once we call the function, we're going to enter into the function body. And at this point is when our parameters get their values. So condition is going to be false, is true is going to be log true, is false is then log false. So we go into the function body now, and it says if condition. And so what happens when you put a variable or an expression in between these 2 parentheses? It's going to force it into a true or false value, into a Boolean value. And so luckily ours is already a Boolean value, so condition is false. So if it's false, it's not going to enter into this block. It will enter into the else block. However, if this was true, so if we change this down here to true, so if condition, so this is the same as saying if condition is true, if the value at condition, stored in condition, is true, enter into this part. And then, since we're in this part of the block, this if block, it's going to call is true. Otherwise, if it's false, it's going to do the else. And then once it calls is true, it just skips to the bottom here. And it basically, you can just imagine it says return undefined. So if it's true, it goes here, and then it skips down there, which means that this else block is never entered if this condition is true. If the condition is false, then this is never run. Yeah. So and then you can read this function as like if true, do this, else do this. So we passed in callbacks, we called them, like but what if we want to add an argument? And so here's an example of us passing arguments to our function. So we have a couple of math functions here. One is called increment, one is called square. So increment just adds 1. Square is going to multiply itself it's going to multiply a number by itself. And here's our function called do math, so I don't have to. And what it does is it takes a number and then it takes a function. And what it does is it calls that function with that number. And so we implement this by just passing it 5, so that's in, and then square, which is the function up here. We enter into the function body, and it's just going to return, square with 5, which is what? Ooh. What is this? This is a math test, 25. And what about this one? 5. So this is just an example of, we just call the function as if it's just stored in a variable name. There's no difference here. So how would we pass an argument here to either is true or is false? What would we have to change to pass an argument? So,
Put it in the function within the if block.
and the first thing we'd have to do like this, right? Assuming that we're getting our argument is being passed in from the parent function, we'd have to put it here. And then, yeah, we just pass it just like this. Or we could just say, even like this, we could say var arg equals 0 or something. And then we can just have our arg inside the function. Or we could do it like that. Either way. And then how would we call this function?
Well, if else, and then put your condition, your true is false, and then your argument, so on.
And this would be a function. This would be a function. And then pass a number or whatever. Maybe a string. Cool?
Now, sorry. Because when we first did some of, when you did the A plus B plus C yesterday, and it was return A plus B, because it didn't care if you had 3 arguments. Even if you don't specify it there in the function definition, the ARG, it's just, so if you don't have that ARG up top there in the function definition, but you ran if else and you had that ASDF at the end, it's just gonna like not gonna do anything with that. It's just like the C.
Exactly. Exactly.
Can you explain why we have to define the arg variable? Like, why couldn't we just, when we actually call the is true function, just pass in the parameter at the time of calling it?
Because, like here, you mean? So if we had this function here. Like where?
Right, and
like
then,
here?
Right, and then when you
Put the ASDF
exactly
in the front in the function indications.
Okay, because this here, this is just a function definition. We're not invoking the function here. So the only way that we can give a parameter a value or pass an argument is when you're actually calling the function. And so we're actually calling the function at this line. We're not calling the function here. We're just passing the definition. So if we were to call the function, you have to have the 2 parentheses.
So how does like if you have a click event in jQuery, I'm just thinking, then you pass the event variable in the callback function? How does that work?
So whenever that element is clicked, jQuery is calling your callback function with that event object. So like so I have an example in the very top. So here, or sometimes you call it E, and you've probably seen it as like E.prevent default, right? Or something like that. Here, you're only defining E as a parameter. So you're just saying, I'm just going to call this E, but you could call it, this ASDF and do it that way. So whenever, say we had a click event on like just a body here, we click on it, and at that moment, that function is called. So this function here is called at the moment of clicking, and that's why we get data for the E. So like the E object or the event object like has data on like where you actually clicked and stuff, and so it's being passed at the time of clicking.
The question is, how does arg get passed to is true and is false if the parameter is only set on if else?
Let's see. One more time.
So how does that arg get passed to is true and is false if it's only set on the if else?
The function definition would have to take a parameter and then use that parameter in its definition.
So you could,
Or you'd have to use the arguments function or the arguments semi-array to get access to it.
so yeah. Maybe this will answer the question. So those are just example functions, but this function then is a function that takes that argument and then passes it to the function, and it will just console.log here x. So x is a parameter. So this is where a parameter and arguments get a little bit tricky. So arg at this point is a parameter. X here is a parameter. ASDF, right, is a value that is an argument. All of these things are arguments in here. So true is an argument. This function definition is an argument. And when we pass ASDF, arg now contains that value. Arg here is now, you can imagine it's ASDF. And that's an argument. And now is true, this x here, and is true is then going to be ASDF. And that's how you follow it through the function.
The follow-up question to that, I think, is do you have to set that parameter in the function definition of is true and is false?
No, you don't. So the other option is if you have no parameters, or you don't know how many parameters, you can use the arguments keyword, which is going to print out an array of the arguments. So if we only pass one argument and it's ASDF, it'll have ASDF in an array-like object. So we covered this yesterday in the function section if you want to review the arguments keyword. It's pretty interesting.